Okay, we got circles part 3. I'm going to specifically clarify the difference between arc measure and arc length, because this is one that students often get confused, not because they don't know the difference, but they just mix up the specificness of the vocabulary. So I actually broke my protractor out or compass out for this one. So we've got 2 circles here. And here's what I want you to think about. This is the same angle, A to the center to B or C to the center to D. That is the same angle in red. And my circles have the same center. They're called concentric circles. Concentric meaning with the same center. And so we get this picture right here. And here's what I want you to think about. We know that based on the fact that this angle in red, this angle in red is a central angle, the vertex on the center, then that means the degree measure of arc AB and the degree measure of CD must be the same. Okay, so I know that the measure of AB arc must be the same as the measure of arc CD because they have the same central angle. This degree measure down here would be the same. They're both central angles, so they equal the intercepted arc. Okay, that's fine. But now I want you to think about this. Suppose these both represented plots of land. I know plots of land aren't normally circles, but bear with me. And I needed to put a fence around the edge. Do I need the same amount of fencing to get from A to B as I do to get from C to D? No. C to D is way longer because the circle itself is bigger. And that's where arc length comes in. The length of AB, arc AB, is not the same as the length of CD. Okay? Arc length is the linear distance along that edge. If I were to take a wheel, a ruler, a measuring tape, and physically measure that distance, that's what arc length is referring to. Measure is how many degrees are you opened up, and we see that regardless of the size of our circles, the measures can be the same. The lengths will not be. Once my circle changes size, the arc length will change for the same given central angle, obviously. The central angle changes, all the measurements can change. So the question becomes, how do we actually calculate that arc length? Well, in order to do that, it's actually quite simple. Arc length, in essence, is a fraction of the circumference. Right? If the circumference is the entire length around my circle, arc length is a piece of that. Well, how do we get that piece? You take the arc measure, divide it by 360, and then times it by the circumference. This gives you the fraction of the circle that you want. This tells you how long the entire circle is. So, fraction of the entire circle gives me arc length. Now, in case you need a refresher, circumference can be found by 2 pi r, or pi times the diameter. I favor 2 pi r, so I'll use that in my calculations. And so we get this idea right here that arc length is equal to arc measure over 360 times 2 pi r. So, as an example, I've got an angle right here. I know that my central angle is 60 degrees. I know that my radius is 10, and they're asking me to find the length of AB. So if I come down here, because it's a central angle, that means my intercepted arc must be equal. So my arc measure is 60 degrees. I know that an entire circle is 360. So I now have the fraction of the circle that I want. And I'm going to times that by 2 pi times my radius of 10. Okay? So if I do a little simplifying with this, 60 over 360 is 1/6. 2 pi times 10 gives me 20 pi. So I end up with 20 pi over 6, or 10 pi over 3 units. Personally, in my calculations, I'm going to favor leaving my answers exact. Leave that pi in there. You don't need to multiply it out. Obviously, if you're going to go to the hardware store and buy some fencing, if you come up and say, I need 10 pi over 3 feet of fencing, yeah, good, right? They're going to laugh at you. You take a calculator, find the decimal, approximate. But for our purposes, I think it's a good practice to keep it exact. Leave pi in your answers. I prefer it that way.